Hi guys, welcome back to my YouTube channel. Welcome back to my YouTube channel. Today we are going to discuss about closure properties of context-free languages. Context-free languages are accepted by pushdown automata. Context-free languages are generated by context-free grammars, which have productions of the form A, where A and N question mark P and N is not a non-terminal and P is a terminal. Properties of context-free languages. Union. If L1, language 1 and language 2 are context-free languages, their union L1 and L2 will also be context-free. For example, L1 A power n, B power n, C power n, where m is greater than or equal to 0 and n is greater than or equal to 1, and L2 A power n, B power n, C power n, where C n is greater than or equal to 0 and n is greater than or equal to 0. L3 is equal to L1 intersection union L2 is equal to A power n, B power n, C power m union A power n, B power m, C power m. N is greater than or equal to 0 and m is greater than or equal to 0 is also context free. L1 says number of A's should be equal to number of B's. L2 says number of B's should be equal to number of A's. Their union says either of the two conditions to be true. So it is also a context-free language. The second is concatenation. If L1 and L2 are two context-free languages, their concatenation L1 dot L2 will also be context-free. For example, here L1 says number of A's should be equal to number of B's, and L2 says number of C's should be equal to number of D's. Their concatenation says first number of A first number of A's should be equal to number of B's. Then number of C's should be equal to number of D's. So we can create a PDA which will push for A's, pop for B's, push for C's, then pop for D's. So it can be accepted by push down automata and context free. Clean closure. If L1 is context free, its clean closure L1 will also be context free. For example, L1 is equal to A power n, B power n, where n is greater than or equal to 0. L1 star is equal to A power n, B power n, where n is greater than or equal to 0 to the power to the star is also a context free. Intersection and complementation. If L1 and if L2 are context-free languages, their intersection L1 intersection L2 need not be context-free. For example, here in L1 says number of A's should be equal to number of B's, and L2 says number of B's should be equal to number of C's. The intersection says both conditions need to be true, but pushdown automata can compare only two. So it cannot be accepted by pushdown automata, hence not context free. Similarly, complementation of context-free language L1, which is star, L1 need not be context-free. Deterministic context-free language. Deterministic CFL are subset of CFL which can be recognized as deterministic PDA. Deterministic PDA has only one move from a given set and input symbol, that is, if do not have any choice. For a language to be DCFL, it should be clear when to push or pop. For example, is the following L1 is a DCFL because of for A's we can push on stack, but for B's we can pop. It can be recognized by deterministic PDA. On the other hand, L3 cannot be recognized as DPDA because either number of A's and B's can be equal or either number of B's and C's can be equal. So it can only be implemented by NPDA. Thus, is CFL but not DCFL. DCFL are closed only under complementation and inverse homomorphism. So, so this is it for today's video, guys. I hope this video is found helpful. Thanks for watching.